Hello, welcome. Today let's try to solve another Leetcode problem, 2594, minimum time to repair cars. So I did this question yesterday, so I used the binary search. So today I just wanted to explain my solution and code it up. So I just wanted to check if I can solve it yesterday, can I solve it today? Just use the same method. Yeah. Now we are giving rex array, so the rex is like random numbers, like 4, 2, 3, and 1, and we also have cars. So we need to return the minimum time taken to repair all the cars. So we need to repair all those cars. So there are 10 cars. So let's check the example first. There is a formula we need to take care. So this R, a mechanic with a rec R can repair n cars in R times n square minutes. So what does this mean? So this means if the R is 4, so the mechanic can choose to repair 2 cars. So if the mechanic choose 2 cars, it means 4 times 2 times 2, it is 16. So for the second mechanic, if he still choose 2 cars, it means 2 times 2 times 2. Yeah, because his rack is 2, so it is 8. And for the third one, if the mechanic still choose to repair 2 cars, so 3 times 2 times 2 is 12. And for the fourth mechanic, yeah, because the rack is 1, if he choose 4 cars maximum, so the result is 16. So it can be proved that the cars cannot be repaired in less than 16 minutes. Yeah, so you cannot find a smaller number than this 16. So it means 16 is the smallest number. Yeah, so this is why we need to return the minimum time taken to repair all those cars. So we are given a problem. If there is an array and there is a car, so this car is a limit. So we need to return the minimum time or the maximum time. Normally, we can use binary search to solve the problem. Because for binary search, we just need to guess the time. Yeah, so for example, this is 16. It meets the condition. So what about if we use a binary search to search for 20? Yeah, if we choose 20, yeah, we can meet the conditions. Why? Because if we choose 20, we can still use these numbers. Yeah, we can at least repair 10 cars. If we choose 20, if we can repair more than 10 cars, like 11 or 12, so it means we can choose little time. So what about we choose 10? If we choose 10 minutes, we cannot finish repairing all these cars. We cannot finish repairing 10 cars. It means we need to find a bigger number. Yeah, so for the next step, if we find a 16, it means this is our result. So actually there are a lot of such kind of problem. It is called binary search with a minimum or maximum value. Yeah, normally we use a greedy idea with binary search to solve the problem. Now let me just to write my template for solving the problem. So normally I'm gonna use a check. So this check is just for my binary search. I will use it later. So inside it will be a threshold. I will give a pass first. Later on, I will explain why I write this function. So for the binary search, normally I need L pointer and R pointer and a result. So I'm going to return the result. So for the L pointer, let's check what is the minimum time. So we are giving the cars and giving the rex. So the rex array is at least 1, and rex I, the value is at least 1, and cars is at least 1. So it means we at least need to take 1 minute to repair the cars, because there's always cars and there is always a rack. If the rack is 1, so 1 times 1 square, we can finish repairing this cars if the car is 1. So what about the maximum? So for the maximum, if the rack is 100, and if a cars is 10 to the power of 6, so this means the maximum is 100 times 10 to the power of 6 times 10 to the power of 6. So it means 10 to the power of 14. Yeah, because square of this number is 12, and then we need to times 100. Yeah, because if there is like 10 to the power of 6 cars, we need to repair. So what is the maximum time? So if there is only one mechanic and his rack is 100, so it means 100 times the square of this number. Yeah, so this is why R is the maximum. And the result we can give a 1 because the result will be updated according to our binary search function. So I'm gonna use the binary search while L less than R. I'm gonna have a mid pointer should be L plus R minus L divided by 2, and then I'm going to use my check function. So the check function is just need to check if it meets the conditions to finish repairing all those cars, and this M actually is my threshold inside the check function. So if I meet the conditions, so what I can do, I can get a result of my value. So if I check M, this is some number in between L and R. So if this is a possible result, so the result should be equal to M. And I need to update the pointer because if this is possible, it means this must be a very big number for the time. So if a big number, if a longer time is impossible, so the shorter time must be impossible. Yeah, so that means it should be go to the shorter time. R should be equal to M minus 1. So if it is not possible, so the L pointer would be equal to M plus 1. So basically this is just a template. You just need to use this template, and you need to understand the binary search and then understand the binary search template. And here is just what we need to get our result. If it meets the condition, we're gonna have a result. Then if this value is too big, we just need to go to a smaller value to check if it is possible. If the value is too small, we just need to check a bigger value if it is possible. So for each kind of a condition, if this is check M, it means always be possible. We need to record it to the result. After that, we're gonna return the result. So the hard part is for this check function. So for this check function, normally we need to understand, the threshold here. So the threshold actually is the time. So for example, this time is just 16. So we need to calculate the time. Normally, we need to, this threshold is given. Normally, this time is given because this is just a guess. We may guess 16 or some other minutes. So this is just a guess. We just use this number, this guess, to check if we can repair at least 10 cars. So finally, we just need to return the count more than or equal to 10. This means we can at least repair 10 cars with this time. If we have a shorter time, the count should be less than 10. It means we cannot repair it. The difficult part is to calculate this count. So from the beginning, the count is 0. Now we just need to look through the array. So for R in ranks, so we take the number like 4, 2, 3, and 1, and then we need to calculate the count. So this count is actually the cars and how many cars we can repair. Let's check, just use an example of this one. So for this one, it is 4 times 2 times 2. So for the number of 16, this is the threshold. If it is 16 and the rack is 4, we need to calculate this 2. So how should we calculate this 2? It's just the math formula. You should use 16 divided by 4 and the square root of this number. It's the same. We just need to use our count plus equal to this number. So this number is the threshold and divided by the rack. Now we just needed to use a square root. Square root of this number. After that, we needed to turn it into an integer, right? Let's just check if this is right. So for example, this threshold is 16. 16 divided by 4, it is 4. Square root of 4, it is 2. So for the integer, it is still 2. So what about we use another example? So for example, this 12. Yeah, just check if this is possible by our formula. Yeah. So if the threshold is still 16, right? So the 16 will be divided by 3. So 16 divided by 3, yeah, equals to 5.333. So square root of this number, it is a 2 point, maybe 2.1 or 2, and int, it is still 2. So it means it seems it works. Yeah. Yeah, because this is 5.3 and square root of this number is more than 2, and int, it is equals to 2. Yes, it means we always choose, we can use int or floor. It should be the same. Now let me just run it to check if it works. Yeah, it seems not working. Expected 16, cost is 6. Expected, so the output is 16. Expected, yeah, the first one works, the second one didn't work. Yeah, let me check if the formula is right. Yeah, let me check with this formula, this one. So this is a 5, 1, and 8, and the result is 16. So if the threshold, yeah, because I used the 10, this is why. Yeah, because the code should be what? The code should be more than the cost. Yeah, sometimes. Yeah, you may forget. Yeah, because this is just an example. I used the first example as 10. That is why the first example works. Yeah. Now I find it is from here. So it should be more than or equal to this cost. Yeah. Now it should work. Now let me just run it to check if this works. Yeah, as you can see, it works. Now let me submit it to check if it can pass for all the testing cases. After that, I will analyze the time complexity. Yeah, because we need to count how many cars. We need to count these numbers. If this count is more than or equal to cars, it means it is possible. As you can see, it's pretty fast. It's yeah, nearly more than 1 second, but it is still okay. Now let's analyze the time complexity. As you can see here, it's 10 to the power of 14. It's a big number, but for binary search, this is just log. If you use a log, so this is not a big number. It is just maximum to, yeah, no more than 50. So the log 2 of this number is no more than 50. And let's check the rex. So the length of rex is 10 to the power of 5. So it means this number, it is n times log k. So k is 10 to the power of 14. So finally, it will be, yeah, no more than 1 times 10 to the power of 7, because this is just 50. Yeah, around 50. That is just my guess, because log of this number is a very small number. So 50 or 60 times 10 to the power of 5. So it is to the scale of 10 to the power of 6. So this is why it can pass for the Leetcode. Thank you for watching. If you think this is helpful, please like and subscribe. I will